Okay, so here we are finishing homework 7.2, section 7.2, part 2. So question number 4. So they give us this fraction times that fraction. The answer is already here for us. How'd they get that? Well, basically you got to factor it, so it's a bunch of factoring. So let's take this part and factor. How do you factor x squared minus 25? Two terms there. That means it's a double-double or a triple-triple. That one's a double-double, right? Because it's x 5 times 5. So it's a double-double. So x plus 5, x minus 5. That makes negative 25, right? The bottom, we got to factor that with the diamond. So what multiplies to be the negative 5, right? You always multiply to be the back number, add to be the middle there. Let me get rid of that. You multiply to be that, and add to be that, so you add to be negative 4. What times what's 5? Well, 1 times 5. How does it make negative 4? Well, the sign in the bottom goes in the bigger. Negative 5 plus 1, right? Multiplies to be negative 5, adds to be negative 4. So that's x plus 1. Oops. X minus 5, either order, times, and then the other fraction is still just x plus 1 over x. Okay, now we're multiplying fractions here, so we're allowed to cross cancel. So x plus 1, x plus 1. We can even cancel straight up and down. Anything on the top with anything on the bottom. What are we left with? Only the x plus 5 here on the top and the x on the bottom. There's the answer. All right. Next one. Now, it's kind of hard to see it on number 2 here, but that's a divide in the center there. That's a divide. So this problem becomes 3x to the 7th over 7x to the divide. And what do we do with divide? We flip the 1 on the right, because dividing is upside down multiplying. So you change to times, and you flip upside down the 1 on the right. You flip this one to there. Why? Because dividing is upside down multiplying, right? Think if I just take 10 and divide by 2, you know that's 5. That's the same as multiplying by the upside down. Half of 10 is also 5, huh? Dividing is upside down multiplying, isn't it? So that's true of all fractions. So therefore, when I want to do this problem, instead of dividing, I multiply by the upside down. Okay, now, what are we allowed to do now? Again, we're allowed to cross cancel when you're multiplying fractions. 7 goes into 14 2 times. 3 goes into 9 3 times. So what number? We're left with a 2 on the top and a 3 on the bottom. Right? 2 on the top, 3 on the bottom. All the other numbers are canceled. What about the x's? Well, on the top we have x to the 7th, x to the 3rd, which makes x to the 10th. On the bottom, x to the 5th, and then an invisible x to the invisible 1, x to the 1. So that's x to the 6th. Those powers subtract. So it's 2x to the 4th over 3, right? 10 minus 6. Because really, there's 10 x's on the top and 6 on the bottom. They cancel, leaving x to the 4th. There's the answer there. Number 6 is kind of the same thing. We're going to, on number 6, it's divide again, as it says there. So we're going to flip the 1 on the right and change to times. So the 1 on the left stays as it was. And then we go times, and we flip the 1 on the right. 8x to the 9th. Over 2x minus 18, like that. So I flipped and changed to times again, because dividing is upside down multiplying. Now, what can I do with that? Well, one thing I can do, this 2x minus 18, I can factor out a 2, huh? Like that. Now, let's cross cancel. X minus 9, x minus 9. 4 goes into 8 2 times. And x to the 8th goes into x 9th, leaving x to the 1. See, those powers subtracted. So what are we left with? 2x plus 4. You can write them in any order. You can put the 2 at the back. Oh, and I forgot the x, huh? We have a 2, we have an x to the 1 now, and an x plus 4. So 2x, x plus 4. What's on the bottom? Oh, another 2. So those 2's will cancel. I didn't see that other 2 in the bottom. So those 2's will cancel, so it's just x times x plus 4. They put it in the opposite order. That's the same thing. All right, let's move on. Okay, number 7. Again, it looks like it's a divide problem, so that means we take the one on the right and we flip it. So we've got x squared minus y squared over x minus y. Change to times because multiplying is upside down dividing, or dividing is upside down multiplying, however you want to say it. Over x. Okay, so I flipped the one on the right and changed to times. And now I got a factor, I can't cancel right now because the pluses and the minuses make all this stuff glued together, you know. I can't like cancel anything when there's pluses and minuses because those are all Costco glued together packages. So instead I'm going to factor this piece. That's a double-double, right? So it's going to be x minus y, x plus y, and the bottom is just x minus y, times, and now the one on the right, this one I'm going to take out an x. GCF, that was just GCF right there. Everybody see that? They both had an x, so I just took out the GCF. Okay, and now can I cross cancel anything? These x's can straight up and down canceling is okay also. X minus y, or I could have canceled it with the other one, doesn't matter. We're left with 1x plus y and 1x minus y. Nothing's on the bottom anymore. So you could leave it that way, it's totally fine. Looks like they multiplied it back out. I don't know why they did that. That's weird. I'm pretty sure they would take this answer too. See what I mean? They just went ahead and re-multiplied it, which seems kind of dumb to me. Boom, boom. Plus xy minus y squared. See, that's just foiling. And then these guys cancel. That's all they did. You don't have to do that on a test, right? A test is just going to be multiple choice, so you just grab the one that matches. So that stuff is not required. All right, let's go on to number 8. Little fresh screen here. So again, divide. So we're going to flip the one on the right and change to times. So we get x squared plus 3x plus 2 over x minus 4 times, and then flip the one on the right, x minus 4 over x squared minus 3x minus 10. Now, got a factor. These will just cancel right away. That's nice. Got a factor. So how does this one factor? We can do a diamond thing. Remember, it multiplies to be the number at the back, adds to be the middle. So it multiplies to be 2, adds to be 3. What times what is 2? 1 times 2. Everything's positive here. 1 times 2 multiplies to be 2, adds to be 3. So this one will become x plus 1, x plus 2. These are gone, right? So I can just stick the other one. So it's just over 1 if you want, times, and then the other one, how does the other one factor? This one, do a diamond, multiply to be -10, add to be -3. What times what's 10? 2 and 5. How does it, the sign in the bottom goes in the bigger, the sign in the bottom is negative. -5 plus 2, that was multiplied to be -10, add to be -3. So that's that, x plus 2x minus 5. So the x plus 2's cancel. We're left with x plus 1 over x minus 5. There it is. All right, on to number 9 we go. Number 9. So this is multiplication. So I don't need to flip anything. So I'm just going to grab this guy and factor out. That's GCF. Take out what's in common. Over 5 times 12 over this is GCF, take out a 6. And then we can cross cancel, x plus 3's cross cancel. 6 goes into 12 2 times. What are we left with? 2x over 5. 2x over 5. There it is, number 9. Okay, so I skipped number 10. I think that one's pretty easy. It's just like the other ones. I'm going to jump to number 11. This looks like dividing, so that means I flip the one on the right. So this becomes x squared minus 9 over 36x times 6xy over 3 minus x. Okay, good so far. Now, what do we do with this? Remember, we always want x in the front, so we reorder it. Minus x plus 3. Remember, when you move them around, they take their baby with them. That minus that's in front of the x, that goes with it. There's nothing in front of 3, which means plus. So you take their signs with them when you reorder them. And then we can't have a minus in front, so you factor out the minus 1, and that makes minus 3, right? Because that'd be negative x and plus 3. All right, so there's how that denominator ends up. So what do we got? And we got to factor this. That's a difference of squares. X minus 3, x plus 3 over 36x times 6xy times, and then this part ends up here, negative 1 times x minus 3. All right, let's cancel. X minus 3, x minus 3. What else? X with x. It's fine to cancel those. They're not plus or minus. They're not glued. No Costco glue there. That's fine. And 6 into 36, 6 times. What are we left with? On the bottom we have a 6 and a negative 1. That's it, huh? On the top we have an x plus 3 and a y. Like that. Now, on the bottom, they pulled the negative out to the front. That's fine, because this is negative 6 on the bottom. Right? You could just make 6 times negative 1. That's negative 6, and that's fine to leave it on the bottom, or you could pull it out to the front like they did. Either way. That makes sense? Let's do number 12. All right, last one here is number 12. Make sure I got it right. Yeah. Okay, it's multiply. Nothing needs to flip. Just a bunch of factoring. So this needs to factor GCF. Take out what's in common. Take out a 5. This is GCF. Take out an x. Leaves 4x plus 1. See, if I multiplied that, it would go back. Next part. This is a difference of squares, x plus 4, x minus 4. Now the hard part is this guy. This guy is a 3 terms with a number. It's a 17 there. With a number in the front. What do we do with that? Slide and divide, right? So that 4 slides to the back to become 16, so you get x squared plus 17x plus 16. Then you do your thing. You multiply to be 16, your add to be 17, so that'd be 1 times 16, both positive. Multiplies to be 16, adds to be 17, so that'd be x plus 1, x plus 16. But now that's the slide. Now we got to do the divide. So you go back and say, okay, now divide by what was in the front? The 4 that we slid. Divide by 4, divide by 4. This part just becomes x plus 4 because 16 over 4 is just 4. This 4 goes back there. So 4x plus 1. There's the factorization. 4x plus 1 times x plus 4. Alright, so all that work was on the side here. Now let's get back to finishing the problem. It's time to cross cancel. What can we cross cancel? 4x plus 1, 4x plus 1. X minus 4, x minus 4, x plus 4, x plus 4. That's great. What's left? Looks like just 5 over x. Done. So there we go. There's the rest of the lecture for, did we get that right, by the way? Yeah, 5 over x for 7.2.